Hello students, very good evening to all of you. Myself Rajeev Singh, I am a plus educator on Unacademy platform and I am shaping the young minds like you for almost past 10 years. So I welcome you all in this Utkrisht session. This is an initiative by us on this Unacademy Accord channel. Here on Fridays, we generally discuss the basic concepts. On Saturdays, we discuss intermediate concepts, and on Sundays we discuss some high level concepts. Dear students, actually this class was session for yesterday, but due to some personal issues I had to reschedule it for today. So no issues. We are going to learn that is what is that sticking friction and sliding friction model in forging. Yes, you learn the metal forming operations, and then you see something, this word comes like sliding friction, sticking friction. So what exactly are these things? Before that, let me just give you some information. This is about Master Blaster Practice Series. Yes, students, this Master Blaster Practice Series is conducted on Unacademy app. You can go and you can watch these free special class series. Though if you have no subscription with you, you can watch these classes, and these classes are going to be very much helpful to you if you are preparing for this GATE exam, because here in this Master Blaster Practice series of special classes there will be 10,000 practice questions for GATE, which are curated by the top educators on Unacademy platform, and this is available for all the different branches: computer science, electrical engineering, electronics communication, mechanical, civil engineering and chemical. Students, if you want to join this session, you will have to download the Unacademy app. There you can go to that special classes, that option you will get there. You go there and then they may ask you a referral code there for joining that class. There will be no fee that will be charged to you, only the referral code will be asked, so you can write and enter this referral code RK007. This is the universal referral code. You can use it for anything. Whenever they ask, give some referral code, use RK007. No issues. For discount and for everything, this thing will work. That is RK007. Now, my dear, moving next. This was Master Blaster series information. This next one is, this is what that we are doing. This Utkrisht. This is also initiative of Unacademy on this Unacademy channel, that is Unacademy Accord. Please do subscribe the channel, like the channel, press that bell icon so that you get yes. तो ये जो मैं बता रहा था, सेकेंड दिस उत्कृष्ट, दिस इज ऑल्सो आवर इनिशिएटिव ऑन दिस अनअकैडमी अकॉर्ड चैनल, जहाँ पे कि हम फ्राइडे को लेते हैं बेसिक कॉन्सेप्ट्स, सैटरडेज को इंटरमीडिएट कॉन्सेप्ट्स, संडे को एडवांस कॉन्सेप्ट्स, नॉलेज फाइट होता है मंडे को, और टेस्ट्स विल बी देयर ऑन एवरी ट्यूसडे. नाउ मूविंग नेक्स्ट, देयर इज दिस अनअकैडमी कॉम्बैट. Unacademy Combat is India's largest weekly competition for GATE. You can access your GATE preparation in 60 minutes. Challenging and original GATE questions will be curated by the best educators, which will be there in the test, and you can take it live to compete with the best. Super fast and fun with all India live. Super fast and fun with all India live leaderboard. Then, my dear, you can identify and improve your weak areas through detailed video solutions. And once you write this test, my dear, what happens that if you get a rank between this 4 and 10, sorry, between this like 1 and 3, if you are under top 3, तो Unacademy का आपको 1 साल का सब्सक्रिप्शन कंप्लीटली फ्री कॉम्प्लीमेंट्री प्रोवाइड करवाया जाता है. अगर आपकी रैंक आती है 4 से 10 के बीच, तो 75% का डिस्काउंट मिलता है आपको अनअकैडमी प्लस सब्सक्रिप्शन पे, और अनअकैडमी कॉम्बैट टेस्ट में अगर आपकी रैंक आती है 11 से 50 के बीच, तो 50% का ऑफ मिलता है अनअकैडमी सब्सक्रिप्शन पे. और जिनका रैंक अंडर 100 है उनके लिए भी कुछ है, दैट इज दोज हु आर गेटिंग द रैंक बिटवीन 51 and 100. Those who are getting the rank between 51 and 100, those who are getting the rank between 51 and 100, for them there is this 25% off on Unacademy subscription. Students, coming to the next part, that information, yes, this combat is there on every week. हर एक वीक अनअकैडमी कॉम्बैट टेस्ट होता है, वहां इनरोल करने के लिए भी आप RK007 कोड यूज कर सकते हो. कमिंग टू आवर न्यू बैचेस दैट वी आर स्टार्टिंग, दिस इज द बैच L of मैकेनिकल इंजीनियरिंग व्हिच is for evolve for GATE 2022 and Ascent GATE 2023 batch L, that is starting on 2nd of June, my dear. Remember, where myself, Rajeev Singh, and other faculties on this Plus platform will be teaching you all the different technical subjects of mechanical engineering, where you will be preparing for GATE. Yes, so this batch is starting on 2nd June. Again, if you want this subscription, you can use the referral code which is RK007, and you will be availed the discount. Chalo dear, so this was about the batch information. Now, when you will be taking the subscription, you will have these two options. One is that of Plus. One option is Plus subscription. Another option that is there is the iconic subscription. What is Plus subscription? You see, once you take the Plus subscription, now what facilities you get? You get the live classes which will be available in recorded mode for the lifetime. For the time for which you have the subscription, the same class will be available in recorded mode as well. Once you are done with the subjects, there will be crash course, weekly test, doubt solving sessions, both English and Hindi languages, rank improvement batches will be there as well. So this is what this inner circle that you get in Plus subscription. This. What if you get iconic subscription? अगर आप iconic subscription लेते हो तो प्लस में जो चीजें मिल रही हैं वो सारी चीजें आपको मिलेंगी आइकोनिक में. दैट इज लाइव क्लास इज रिकॉर्डेड मोड, क्रैश कोर्स, वीकली टेस्ट, डाउट सॉल्विंग सेशंस, इंग्लिश एंड हिंदी लैंग्वेज, रैंक इंप्रूवमेंट बैचेस. अपार्ट फ्रॉम दैट आइकोनिक में क्या मिलेगा आपको? पर्सनल कोच, one-on-one गाइडेंस ऑन प्रिपरेशन स्ट्रेटेजी, स्टडी प्लानर आपके लिए कस्टमाइज्ड तैयार किया जाएगा, कस्टमाइज्ड स्टडी प्लानर, डेडिकेटेड डाउट क्लियरिंग इंस्ट्रक्टर्स होंगे आपके पास, प्रिपरेटरी स्टडी मटेरियल प्रोवाइड करवाया जाएगा, स्पेशल और नोट्स होंगे वो प्रैक्टिस के लिए, स्टडी बूस्टर सेशंस होंगे आपके, यू विल रिसीव एसेंशियल गाइडलाइंस वाया रेगुलर वर्कशॉप्स, एंड दीज वर्कशॉप्स विल बी डन बाय the top educators on Unacademy. Along with top educators, my dear lovely students, there will be the toppers themselves of the different exams. Yes, then my dear, your test analysis for you will be done personally. Personalized test analysis will be there, my dear. So these are the facilities in iconic apart from Plus. Coming to the fees part. Yes, dear, if you are preparing for GATE 2022, I will suggest you that you go for this 1-year subscription. If you are preparing for GATE 2022, I will tell that okay, go for 12-month subscription, which fees is by the way 30,250. But my dear students, if you apply the referral code, RK007, fees discount will be there, and the fee will become 27,225. If you are preparing for 2023 GATE, then I will recommend go for 2-year subscription. Yes, 2 years, so that you can easily prepare for the upcoming ESE exam as well. Yes, and that is going to cost you less. Again, you can use there also the referral code RK007 for maximum possible discount. Thereafter, my dear lovely students, you see 12-month subscription for iconic. If you are taking iconic subscription, if you are planning to take iconic subscription for iconic, you see 12-month fees is 50,250, and upon discount, upon applying the referral code, my dear RK007, your fee will decrease and will become 45,225 rupees. Great. So this was the information that I wanted to give to all of you. Now coming to today's class, where I am about to discuss this sticking friction model and sliding friction model. I am about to discuss this sticking and sliding friction model. Yes, and few days ago on Plus platform, I had taken a class on this sticking and sliding friction. So instead of wasting the time in writing the things, I have come up directly with the same PDF which I had given to them during their live session. Yes, which I had given them as the notes. So here we are there to understand what is this sticking friction and sliding friction, my dear lovely students. Look at this. For calculating the pressure variation during the forging operation or forming operation, what do we do is we go for slab analysis. What is that slab analysis? Let us say this is the workpiece down here, white color, and these are the two dies at top and bottom, yellow color. There we are taking this small element, and this is the slab. That's why it is called as slab analysis. So there we are taking a small element and we are looking at that small element of the product which is being forged between these two dies. Rectangular dies are there actually. In between them, this product is being forged. So let us say there is this element. This is the center line. This is the total workpiece length, or you can say width, any dimension, length or width, anything you can say. So this is the center line. Total length of the workpiece is L, and half of that A, half of that A. So that means total length L is equal to 2A. Now there, from center at certain x distance, from center at certain x distance, from center at certain x distance, let us take this dx element. Yes, a slab of thickness dx element, dx, this element we have taken. Upon this element, if you look at the stresses which are working, then what will be the stresses there on this element? You see, this is that element. Since we are forging it, there will be a material flow radially outwards. Since we are forging it, there will be a material flow radially outwards. If there is a radial outwards material flow, then here at the interface of the die and the workpiece, die and this element, there will be in opposite direction this frictional shear stress tau xy. There will be this frictional shear stress at the interface tau xy, my dear lovely students, and yes, there will be a pressure P. There will be pressure P, normal pressure. Yes, Deepak, yes, you are getting this, I hope. So continue with me, you will understand this whole mechanism. This is really beautiful, that how does the sliding and sticking friction, Deepak ji, varies there in the forging operation. Whether it will vary exponentially or whether it will vary linearly. I hope you understand, Deepak ji. By the way, Deepak Kumar, from where are you? Which college? Come on, write in this comment section. Meanwhile, we discuss this. Okay, come on guys. So, as the material is flowing radially outwards, on this material, the stress will be into the opposite direction. The frictional shear stress will be in the opposite direction. That is tau xy. And the pressure which is there, that is what? P, perpendicular direction. Yes. Now, my dear, on this element, let us say here, along the x-axis, we have this stress sigma x, and at dx distance, there will be a variation in this stress. It becomes sigma x plus d sigma x. Now, my dear, initially the thickness of this, at the time of forging, this thickness is h. Now, let us balance the forces in the x-axis direction. Okay, in the x-axis direction. This sigma x is acting here, sigma x plus d sigma x is acting there, and then into the screen, this element will have certain dimension. Into the screen, this element will have certain dimension into the screen, and that dimension we are taking unity so that we can easily derive the equation. Nothing else. Okay, we are taking it as unity. Whatever inside the screen is there, that is unity. Okay, and why are we taking this unity? For the easy analysis. So, my dear students, if you look at that area on which this sigma x stress is acting, if you look at that area upon which sigma x stress is acting, that area, my dear lovely student, will be this dimension h. From here to there, this dimension h multiplied by into the screen, that will give that area upon which that stress sigma x is acting. The total load will be there, sigma x into h, because inside that dimension is unity. H into 1 is the cross section upon which the stress sigma x is acting. Sigma x into h into 1. Yes, that will be the force along that x-axis. What is the force here? Here the stress sigma x plus d sigma x, because it is at certain distance dx. My dear students, sigma x plus d sigma x here, and then cross section area is same, h into 1. So there that force, but in the opposite direction, is sigma x plus d sigma x multiplied by h. Now my dear students, one more thing, this is tau xy. Yes, this is tau xy there, this is tau xy here. That is also acting into this opposite direction. That is the frictional shear stress, and upon which area it is acting. Upon which area it is acting. You see, this much is that dx. Inside that cross section will be there upon which tau xy and this p is acting, and that area inside will be, this dx multiplied by inside the screen, that dimension I have told you, unity. So that area will be nothing but dx unit square multiplied by tau xy. That will be the force there and the same force here. Now let's balance the forces along x-axis. Let's balance the forces along x-axis. So here I have already balanced it for you. Here I have already balanced it for you. Look at this, my dear. Sigma x into h here, yes, minus, you see, in the opposite direction this force will act, sigma x plus d sigma x into h, that is there, and then tau xy at the top, tau xy at the bottom of this element, so that will be 2 tau x y into dx, yes, because dx was the area. That summation must be equal to 0, and when we simplified this, that is what we multiply this h with sigma s x, this h with d sigma x. What did you get? You got that sigma x into h minus sigma x into h minus d sigma x h minus 2 tau x dx is equal to 0. Sigma x into h, sigma s कैंसिल हो गया. यहां से क्या मिला हमें? d sigma x multiplied by h is equal to minus 2 tau x by dx, and then d sigma x upon dx. Yes, d sigma x upon dx will be equal to minus 2 tau xy upon h. Now, dear students, let us say this is your equation number 1. Now, let us consider that this deformation is happening under this plane strain, von Mises criterion of failure. According to that, the two principal stresses, sigma 1 minus sigma 3, will be equal to 2k, where k is called as the yield shear strength of the material, and this k, yield shear strength of the material, is equal to the yield strength under the uniaxial tensile test, that is sigma y upon under root 3. So my dear, this term will become 2 times sigma y upon root 3, where sigma y is the uniaxial tensile stress. Okay, now, but instead of writing 2 sigma y by root 3, let us say 2 sigma y by root 3 is a term called as sigma naught dash, so that we will not have to write, again and again and again 2 by root 3 sigma y, 2 by root 3 sigma y. Instead, you replace it by sigma naught dash. Come on, guys. So, my dear, if you apply this von Mises criterion here, and let us say the principal stresses which are there are this one, sigma 1 is this pressure P, and sigma 3 is this sigma x, then this under the von Mises criterion of failure can be written as P minus, sigma 1 is P, sigma 3 is sigma x is equal to 2k. Yes, great. So we can write this P minus sigma x is equal to 2k, and 2k we have assumed to be like to write it as sigma naught dash. Come on, guys. So what we did, we differentiated. dp by dx minus d sigma x by dx is equal to 0. dp by dx is equal to d sigma by x by dx, and you already know from here you can write dp upon dx is equal to minus 2 tau xy upon h. There we got na. D sigma x by dx is equal to minus 2 tau xy upon h, and here you see, my dear, dp by dx is equal to d sigma x by dx, and d sigma x by dx from the force balance we had already got minus 2 tau xy upon h. We brought this pressure dp upon dx and tau xy h relation here. Now, my dear, you see, this derivation that we are doing, this derivation we are doing only for the sliding model of friction. What is sliding model of friction? That, my dear, there the Coulomb's law will be valid. That means there this frictional stress which is acting there na, tau xy, can be taken as mu p, mu px, can be taken as mu p. That is the Coulomb's law will work there under the sliding model of friction. So here, my dear lovely students, this dp upon dx that you got minus 2 tau xy upon h. Instead of 2 tau xy, you can replace it by mu p, because you are assuming that there is no sticking. There is only one thing, slipping is going on there. Yes, no sticking, only sliding friction is there. That's why we can write mu p, otherwise we cannot write mu p in place of tau xy. Come on, guys. So this gives us dp upon p, you see, is equal to minus 2 mu upon h, minus 2 mu upon h dx. Let us integrate it. If you integrate dp by t upon integration ln of p, my dear, 2 mu by h dx upon integration minus 2 mu x upon h. Yes, there will be some constant. Yes, there will be some constant. Now, my dear, how to find this constant? For finding this constant, what are we going to do? We are applying the boundary condition. We are applying the boundary condition. My dear lovely students, look at this. This dx element is at a distance x from the center. This dx element is at a distance x from the center. My dear lovely students, this situation at a distance x is equal to a means you are reaching the free surface. At x is equal to a, you are reaching this free surface. So at x is equal to a, how much will be this sigma x? My dear, at x is equal to a, my dear, at x is equal to a, at x is equal to a, as you are applying the boundary condition, my dear, at x is equal to a, you are applying the boundary condition, at x is equal to a, sigma x will become 0. Why exactly sigma x will become 0 at x is equal to a? Because this surface is free surface, there the stress in this direction will be 0 at the free surface, the stress will be 0. Very simple, you learn this instance of material. So my dear lovely students, what happened? At x is equal to a, sigma x is 0, we apply the boundary conditions. So from there you will get that this sigma naught dash, that is 2k, is p minus sigma x. Sigma x is 0. Sigma x is 0 at x is equal to a. At x is equal to a, sigma x is 0. So this 2k, that is sigma naught dash, will become p. Very simple. Only pressure, that is pressure during forging at the free surface. The pressure during forging at the free surface will be equal to sigma naught dash, that is 2 sigma y upon root 3. और शुरू से पढ़ रहे हो तो समझ में आ रहा। चल, you got ln c is equal to, from here ln c is equal to p sigma naught dash, p sigma naught dash with the boundary condition. Sigma naught dash, ln c will become sigma naught dash, ln p is equal to ln sigma naught dash plus this 2 mu x upon h at x is equal to a, 2 mu a upon h. You got ln c value, you got this constant value ln c, you got this constant value ln c, my dear. Now you look at this. If you put this ln c there in equation number c, put this value of ln c then in the same equation, what are you going to get? You see, ln p is equal to minus 2 mu x upon h plus ln c की value ln sigma naught dash plus 2 mu a by h. You kept it here. From there you got ln p is equal to this ln sigma naught dash we brought out, 2 mu x upon h we sent in, and then we took common 2 mu upon h is equal multiplied by a minus x. This is a simple simplification, nothing else. Yes, you are getting this is simple simplification, nothing else. So my dear, further upon simplification, ln p was there equal to ln sigma naught dash plus 2 mu upon h into a minus x. Further simplification, p will become exponential, this exponential of this whole term, and that upon simplification will give you sigma naught dash multiplied by exponential of sigma naught dash multiplied by exponential of 2 mu upon h multiplied by a minus x. So at any distance x from the center, this will be the pressure during the forging operation. Okay, sound was not audible. Yes, now is it clear and loud? Yes, yes, loud and clear. Coming sound? Okay, yes. Corona and population control, sound is not audible. Now it's audible. Come on. Now my dear, let us now think of the situation that what is happening at center. You know, at center, what's going on? Try understanding this. At center, you know, my dear, at center, this is the center line, x will be 0, x will be 0, as x is 0 here, and if you place that x value under that pressure equation that you derived, you will get P is equal to sigma naught dash exponential of 2 mu A upon H. And you think of this situation for any x value, starting from center up to A, 2 mu A upon H is going to be maximum. That is, pressure during forging at the center will be maximum. Pressure during forging at the center, my dear, it's going to be maximum. Yes, pressure near the center of that slab which is being deformed under those two flat dies, maximum pressure will be there at the center, and then towards the free surfaces, or towards A, from x is equal to 0 towards A, pressure will decrease, and at free surface, I already told you, pressure becomes equal to sigma naught dash. Pressure becomes equal to sigma naught dash is equal to 2 sigma y upon root 3. My dear lovely students, and this decrease that will happen will be symmetric on both sides now. And this decrease will be what? Exponential. The pressure will decrease exponentially from center towards the free surface of the product being forged between those two flat dies. Yes, this exponential friction hill, this exponential pressure variation is actually for the deformation happening under pure sliding condition. No sticking friction. No sticking friction. What is a sticking friction, my dear? You see, there, what is happening? There is this frictional shear stress, not tau xy. Tau xy, this frictional shear stress is there, na? Oh, corona and population control. Did you understand? Great, awesome. My dear, tau xy, this tau xy is the frictional shear stress. Sliding friction is happening, means material of that slab is flowing without any sticking. Why exactly sticking happen? Why exactly the sticking will happen? My dear lovely students, if this frictional shear stress which is acting there becomes more than the yield shear strength of the material, then what will happen? That surface will have those, surface are never like two, or surfaces are rough. Yes, surfaces are rough. If surfaces are rough, my dear, it's like that their surface finish is not like always great. So that is like die surface, and bottom here there will be this workpiece surface. When the frictional shear stress acting there becomes more than the yield shear strength of the metal flowing down here, these things will start to stick, and these micro asperities will form there. Under this condition, when the metal is flowing, actually this will have to be broke, this will have to break, this will have to break, this sticking will have to be later on break, and that is what we call as deformation under sticking. Deformation under sticking, my dear. Yes, so now let us go and try learning what is this sticking condition of friction. What is this sticking condition of friction, my dear? Let me show you. For that, let me first upload one more PDF. Because if I start doing the slab analysis here now, that is going to take a lot of time and the class is going to become boring. So I have already done this for you and I am uploading this for you. Yes, if I do it now, yes, I know that analysis is like a boring part. The result makes you happier. Yes, that analysis is a boring part. Oh, Corona, you are my plus student. That's great, my dear. So yeah, it's a good revision, na? It's a good revision that's going on. Okay, let it just come. Same thing I had taught you guys, I think. Same PDF is there that I have downloaded and I'm discussing this. Listen. It is being inserted. It may take some time, but meanwhile. hold on, came. Great. Okay, this we found mean pressure, and yes, here there will be sticking. Come on guys, you see what is this sticking friction condition? As I told you, the same thing is written there. A sticking friction occurs when interfacial frictional shear stress becomes equal to or more than the shear strength of the workpiece. Yes, when the interfacial frictional shear stress becomes equal to or more than the shear strength of the workpiece, the deformation will start under the sticking friction model, because then sticking will start at the interface, and micro porosities will start to appear, asperities will start to appear, that I had shown you. So there, that means tau xy will become equal to tau y, and let us say that is equal to mk, where this m, my dear, is what we call as frictional factor. M is what we call as frictional factor. By the way, my dear students, if it is a perfect sliding condition, for that m will be 0. For that m will be, my dear, 0. And if it is perfect sticking condition, this m value will be 1. Perfect sticking, m value will be 1. That is, the tau xy is equal to yield shear strength. Yes, so great. You had already this equation that we had derived from force balance. dP upon dx is equal to minus 2 tau xy upon h. Great. So tau xy is now how much, my dear? It's not mu p. Mu p is under Coulomb's law, when pure sliding is there. If sliding is not there, you cannot write tau xy to be equal to mu p. Instead, you will have to write it as mk, where m, my dear lovely students, is your friction factor. Yes. Now, my dear, dP upon dx is equal to minus 2mk upon h. dP will become equal to minus 2mk upon h into dx. Let us integrate it. Both sides. When you integrate it, my dear, what are you going to get? You see, 2k term, this 2k term, my dear, this 2k term is what? Sigma naught dash. Now, we have already assumed it. So this we wrote as sigma naught dash. M is further a constant here. M comes out. H is there, that comes out. That is dx only there. So upon integration, you are getting pressure P is equal to sigma naught dash M dx upon integration x upon h plus c. Let us apply the boundary conditions and try finding what is the value of c. If you, my dear lovely students, apply the boundary conditions, that is at x is equal to a. You see, x is equal to a. X is equal to a means this slab which is being deformed at x is equal to a means what? At x is equal to a means what? Free surface. Top there is a die. Bottom here, there is a die. At x is equal to a, this is a free surface. Free surface, that means the stress will be 0. Yes, so there, at free surface, the stress will be 0, my dear. So there, this pressure I had told you, there also, this pressure becomes equal to how much? Sigma naught dash. From where? Von Mises criterion. From where? Von Mises criterion. You know, principal stresses difference, sigma 1 minus sigma 3 is equal to 2k. 2k is sigma naught dash. Sigma 3 becomes 0, so sigma 1 is equal to 2k. That is what does sigma 1 p is equal to sigma naught dash. Understanding? Now, come on, guys. Here, we can write this c value is equal to p plus this. C value is equal to p plus this. Upon applying this, you know, c value here you can write at boundary condition, x की जगह a आ जाएगा, c is equal to sigma naught dash m into x की जगह a आ गया, a by h, p की जगह sigma naught dash आ गया. Let us put these values, all these values in this equation. And you will have the pressure. Yes, put the c value in this equation. P is equal to sigma naught dash m into x by h plus c. Put this c value there. So if you put this c value, constant value there, this pressure becomes there. If you put P is equal to sigma naught dash m minus में into x by h plus sigma naught dash m a by h plus sigma naught dash. हमने क्या किया यहाँ पे? Sigma naught dash plus इसको simplify किया, sigma naught dash प्लस इन दोनों को साथ में ले आए और सिग्मा नॉट डैश एक्सपोनेंशियल. सो if you plot both conditions all together, you see this is what will be there. In both the cases, at the free surface the pressure will be sigma naught dash. In both the cases maximum pressure will be there at the center line, but look at those values, one exponential, another one is linear, and calculate from both cases the pressure at the center. You will find that in case of sliding model of friction, at center pressure will be maximum. Sticking, that pressure maximum will be lesser than that of the maximum pressure of the sliding condition. Sticking के केस वाला जो maximum pressure होगा वो sliding के केस वाले maximum pressure से कम होगा मेरे दोस्त, कम होगा, क्योंकि ये rise linear है, ये rise exponential है for the same given distance. इसलिए undoubtedly sticking वाला जो friction होगा, जो pressure होगा वो कम होगा maximum किससे? sliding वाले maximum pressure से. चलो my dear, तो यू कैन सी देयर माय डियर, इस रीजन की अगर हम बात करें, जैसा इस रीजन में हो रहा होगा, जैसा इस रीजन में हो रहा होगा, वैसा ही सेंटर लाइन के उधर भी हो रहा होगा. यहां देखो, यहां पे क्या है ना, स्टिकिंग का प्रेशर जो है वो कम है, स्लाइडिंग वाला प्रेशर ज्यादा है. स्टिकिंग वाला प्रेशर कम है, स्लाइडिंग वाला प्रेशर ज्यादा है ना. तो अगर स्टिकिंग वाला प्रेशर कम है, स्लाइडिंग वाला प्रेशर ज्यादा है, तो मेरे प्यारे भाइयों, दोस्तों और बहनों, स्टिकिंग वाला प्रेशर कम है, स्लाइडिंग वाला प्रेशर ज्यादा है, तो डिफॉर्मेशन तो कम ही प्रेशर पे स्टार्ट हो जाएगा ना. मतलब इतनी दूरी तक सेंटर से, देखो 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 देखो, सेंटर से माय डियर, सेंटर से माय डियर लवली स्टूडेंट, सेंटर से माय डियर लवली स्टूडेंट, इतनी दूरी तक स्टिकिंग फ्रिक्शन के अंडर होगा डिफॉर्मेशन, क्योंकि इसके कारण जो यहां पे लग रहा है प्रेशर जो डिफॉर्मेशन के लिए चाहिए होगा वो कम चाहिए होगा. मतलब अप टिल दिस डिस्टेंस माय डियर, अप टिल दिस डिस्टेंस, यहां से यहां, सेंटर से यहां तक के डिस्टेंस के लिए या सेंटर से यहां तक के डिस्टेंस के लिए दोनों तरफ तो सिमेट्रिक है. क्या होगा? जो डिफॉर्मेशन प्लेस करेगा दैट विल टेक प्लेस अंडर द स्टिकिंग मॉडल. बट इसके बाद क्या देख रहे हो, इसके बाद स्लाइडिंग वाले प्रेशर कम हो जा रहा है, स्टिकिंग वाला प्रेशर ज्यादा है, तो इस डिस्टेंस के बाद जो होगा डिफॉर्मेशन दैट विल टेक प्लेस अंडर स्लाइडिंग कंडीशन. मतलब सेंटर से एक सर्टेन डिस्टेंस लेटर से एक्स तक जो प्रेशर का वेरिएशन होता है वो स्टिकिंग वाले केस में वो कम होता है स्लाइडिंग वाले केस से, इसीलिए डिफॉर्मेशन जो होता है वो स्टिकिंग के अंडर होता है. और एक्सेस डिस्टेंस के बाद ए डिस्टेंस तक जो होता है डिफॉर्मेशन, उसमें यह देखा जाता है कि स्लाइडिंग वाला जो मॉडल है वो प्रिवेल करता है, क्योंकि स्लाइडिंग वाले प्रेशर्स कम होते हैं और उसी के अंडर में डिफॉर्मेशन होता रहेगा, तो ज्यादा प्रेशर क्यों वहां पे लगेगा? स्टिकिंग वाला. तो अगर दोनों को साथ मिला के देखें कि जब स्टिकिंग और स्लाइडिंग दोनों फ्रिक्शन साथ में काम करते हैं तो सेंटर से सर्टेन डिस्टेंस तक, जो कि लेटर से दिस एक्सेस डिस्टेंस है, स्टिकिंग के अंदर डिफॉर्मेशन होगा, और उस एक्सेस डिस्टेंस से लेकर के ए डिस्टेंस तक जो डिफॉर्मेशन होगा वो किसके अंडर होगा? स्लाइडिंग के अंडर होगा. दैट इज हाउ वी एनालाइज द स्टिकिंग एंड स्लाइडिंग मॉडल ऑफ फ्रिक्शन. अदर स्टूडेंट्स, डियर स्टूडेंट्स हु आर नॉट प्लस सब्सक्राइबर्स, माय डियर, देखो वेट मत करो, अच्छे ब्यूटीफुल कॉन्सेप्ट सीखने हैं, समझने हैं, लेट बिल्कुल नहीं करना है. सीधा तुम लोगों को क्या करना है, प्लस का सब्सक्रिप्शन ले लेना है, और प्लस के सब्सक्रिप्शन लेने के लिए वहां पे आपको रेफरल कोड डाल देना है RK007. यस, एंड देन कम देयर एंड आई विल बी देयर टू गाइड यू ऑल. मतलब मस्त तरीके से एक एक कॉन्सेप्ट के अंदर घुस के समझेंगे हम लोग. हाँ प्रतीक, समझ गए तुम? मतलब इसका तुम समझे तभी होगे जब तुम फॉर्मिंग पहले थोड़ा बहुत पढ़े होगे. प्रतीक बताओ कमेंट सेक्शन में, थोड़ी देर बात ही कर लेते हैं. पढ़ा जो है वही समझेगा, नहीं तो फिर तो भाई वो फ्रस्ट्रेट हो जाएगा. ये सर हो क्या रहा है? मतलब फोर्जिंग में सर ये क्या कर रहे हैं सर? एक्सपोनेंशियल, लीनियर, मतलब ये सब क्या कर, फ्रिक्शन क्या दिख रहा है सर? ये सब है ना. ग्रेट प्रतीक. बाय द वे, इट वाज ऑसम सेशन विद ऑल ऑफ यू. मैंने चाहा कि चलो बिना टाइम वेस्ट किए हुए, क्या होता है ना, लोग इस एनालिसिस को देखते भी है ना. सबसे बड़ी बात क्या है, कहीं कहीं ये देख भी लेते हैं ना एनालिसिस को, तब भी नहीं समझ पाते हैं। तो मैंने कहा कि फालतू में टाइम वेस्ट करना, ये ड्रॉ करना और फिर ये सारे इक्वेशंस लिखना, सी डालना, बाउंड्री इक्वेशन डालना, ये करना, अभी जस्ट पढ़ाया था। देखो ये अक्टूबर 27 2020 को पढ़ाया था मैंने अनअकैडमी पे ही, ठीक है, ये पढ़ाया हुआ है, देख रहे हो ना, मेरा ही लेक्चर पढ़ाया हुआ है। राजीव सिंह लेसन 14 अक्टूबर 27 2020 ये पढ़ाया था मैंने, देखो। तो मैंने सोचा कि क्यों भैया डायरेक्ट उठा के ही डाल देता हूं यहाँ पे, ठीक है। अच्छा प्रतीक मेरे से नहीं पढ़े थे, किनसे पढ़े थे, किनसे पढ़े थे प्रतीक यार, किनसे पढ़े थे, मेरे से नहीं पढ़े थे तो बताइए 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 बताइए। आज तो कुछ थोड़ी बात भी कर लेते हैं, किनसे पढ़े थे। बोलो कोई डाउट आउट है तो पूछ लो, कोई डाउट वाउट है तो वही पूछ लो फटाफट यार, डाउट वाउट है तो कुछ भी पूछ लो यार। बहुत दिनों के बाद मैं यूट्यूब पे आया हूं, अवतरित हुआ हूं, मैं कम आता हूं यूट्यूब पे, प्लस क्लासेस मैक्सिमम लेता हूं, बट सोच रहा हूं कि यूट्यूब पे लू क्लासेस, मजा आता है यूट्यूब पे यार। हाय कोरोना इज मोटिवेटेड बाय माय टीचिंग, दैट्स ग्रेट, बट यू आर कोरोना यार। इफ कोरोना इज मोटिवेटेड तब तो प्रॉब्लम है। हे डू नॉट मोटिवेट यू कोरोना। चलो डाउट आउट है कोई, इसमें कोई डाउट है कि कुछ ऐसा हो जो नहीं समझ में आया हो भैया, कोई बहुत बड़ा लैपलास और फूरियर तो नहीं लगा इस एनालिसिस में है, इसमें बहुत बड़ा लैपलास और फूरियर तो यूज नहीं हुआ है ना इस एनालिसिस में, ठीक है। नहीं है डाउट, मतलब नहीं है डाउट, आई कैनॉट सी एनी डाउट ऑफ योर्स इन द कमेंट सेक्शन। ओके दैट्स ग्रेट ऑसम। चलो डीपीपीज वगैरह भी दे रहा हूं आजकल, पता है ना, माई सेल्फ एंड मारुति तिवारी, नाउ वी आर टुगेदर हैंडलिंग द स्टूडेंट्स एंड देयर इज अ ग्रुप मेकार्मी, वहां डीपीपीज तुमको मिलते हैं, सॉल्व करो डीपीपी, सॉल्व करो, ठीक है। सब्सक्रिप्शन खत्म हो गया तो क्या, मेरे को कांटेक्ट कर लेना ना सर कैसे करना है, तुमको तो पता है कि अगर मेरे स्टूडेंट रहे हो तो मेरा नंबर भी होगा तुम्हारे पास, कांटेक्ट कर लेना, नहीं तो अनअकैडमी ऐप पे मैसेज कर देना, नहीं होगा नंबर तो बता देंगे। डीपीपी सॉल्व कीजिए अब, ठीक है, रैंक इंप्रूव करना है, इस बार फोड़ देना है, इस बार फोड़ देना है भाई, कोरोना के अंदर ही फोड़ना है इस बार, ठीक है। चलो बाय, सी यू, गुड नाइट, टाटा, बाय बाय, गुड नाइट।